Hey, what's up everybody? This is Brian with Radical Prep and my new channel now, Radical Nursing. I'm actually a nurse and I went to school at Stony Brook and I remember what it was like to study for the NCLEX. It sucked. It sucked even more when I had to wait for the results after taking the test. It's probably the worst 2 days of your life. But for you guys to get there, you're going to have to answer some math questions, and that's what I'm here to do today, is to help you with some math questions. So we're going to be doing the NCLEX style math questions from the Saunders book. This is the one that I bought when I was at Stony Brook. So let's take a look. We're going to look at chapter 17 and I'll show you how to do some of those math style questions. All right, so we're going to do question 141 here. This is on page 193 and it goes like this. A healthcare provider's prescription reads 1,000 ml of normal saline to infuse over 12 hours. The drop factor is 15 drops per 1 ml. The nurse prepares to set the flow rate at how many drops per minute, fill in the blank, and round to the nearest whole number. So one of the things I like to do when doing these problems, I would underline what you actually want. That's a huge help to help you figure out what you want. I know it's kind of redundant, but so just underline it. Drops per minute. That's what we gotta get our equation in, drops per minute. So if you're one of those people who likes an equation and plugging in, we've got a very simple equation for you to use. You're just going to use the volume of what you're dealing with here times the drop factor. Okay. All divided by time in minutes. If you can remember this, you're going to have a good time on the NCLEX. Okay. So volume, what are we dealing with? Well, the order is for 1,000 mLs. So put it in. Just plug it in. 1,000 mLs. What's the drop factor? The drop factor is 15. So we just plug it in. Now, I just want to explain that plugging in is nice, but you should have an idea of what the heck you're doing. If it's 1,000 mLs of normal saline and it's going in at 15 drops per ml, that means that to get 1 ml, it's got to drop 15 times. All right. So that's why you're doing 1,000 times 15. That's all the drops that it's going to take. So just felt like I should explain that so you actually have some sense of what you're plugging in. We're getting the total amount of drops on the top here. And what do we want on the bottom? Well, we want drops per minute, right? That whole thing is drops per minute. So the only problem is this wants to go over 12 hours, right? 12 hours. But I can't put 12 hours in the bottom. So I got to get rid of it. What am I going to put? Well, I got to convert 12 hours to minutes. So 12 times what? You got to say 60, right? 12 times 60, 0, 0, 12, carry the 1, 72. You can use the calculator. I'm just doing it over here. So 720. So now I'm definitely using the calculator. So that's 720 minutes. Now let's pop it in. That is 1,000 times 15 equals, divided by 720, 20.8, 20.833, repeating, which is just 21 drops, and I should really put GTT, but I'll just put drops for now, drops per minute. That's your answer. So we can put that right in there. All right, we got number 142 here, and this one says a healthcare provider's prescription reads to administer an IV dose of 400,000 units of penicillin G benzathine bacillin. The label on the 10 ml ampule sent from pharmacy reads penicillin G 300,000 units per ml. So in that 10 ml ampule, the concentration is 300 units per ml. The nurse prepares how much medication to administer the correct dose. So when they're saying how much medication, remember you're probably drawing this up in a syringe if you're giving it IV. So it's going to be, really they're asking how many milliliters are you going to draw up, right? So there's an equation that they give you in the Saunders book to do this. I just want you to think flexibly about numbers and show you that you can totally write this out when you are a nurse. You do not want to give incorrect doses, but let's get in the habit of trying to think on our feet a little bit, okay? So I'm just going to write down, if we know it's 300,000 units per 1 ml, let me ask you a hypothetical question. If it was 600,000 units the providers asked you to give, how many mLs would you give? Well, if it's 600,000, it's twice the mLs, so it's just 2. If it was 900,000, it'd be 3 times the mLs. So what's my point? my point is this is asking for 400,000 mLs. So we know it's going to be bigger than 1 ml, but the problem is if you're not a math person, you might say, I don't know how much bigger is it really going to be. So to figure that out, all you got to do is put 400,000 all over 300,000, and you can divide it out, or you can just cross out the zeros, and you get 4/3, which is equal to 1 1/3. And if you divide it on the calculator, which is totally fine, you get 1.333. Repeating, which just rounds to 1.3. So that's all you do. You give 1.3 mLs. And that should kind of make sense. And you can look in the textbook. I'll go over again that formula for finding out these answers, but it's pretty much the same thing as what I did. So we'll move on. All right, number 143. A healthcare provider's prescription reads potassium chloride 30 MEq to be added to a 1,000 ml normal saline solution and to be administered over a 10-hour period. The label on the medication bottle reads 40 MEqs per 20 mLs. The nurse prepares how many mLs of potassium chloride to administer the correct dose of the medication, fill in the blank. So what are we actually looking for? Do we need to know anything about that 1,000 mLs of normal saline? No. We just want to know how many mLs of potassium chloride to give. So I'll show you two ways to do this. The first way is the intuitive way, or just think about it. You've got 40 MEqs and 20 mLs. So when you look at that, you should notice that the MEqs is twice the amount of mLs, right? It's a 2-to-1 ratio. Whatever the mLs are, just times it by 2 to get the MEqs. So if I know my MEq that they order is, or what the providers want, is 30, well, what times 2 gives me 30? And it's 15, and you're done. 15 mLs. So that's like a quick way to do it. If you didn't know that, you literally could just do cross multiplication like you did in high school. You could do 40 MEq all over 20 ml. And we want 30 MEq. We don't know how many mLs it is, right? Cross multiply, so this times this, top times bottom. So that's going to be 30 times 20, which is 600. This is 40 times x. That's an x, right? We don't know what's there. That's 40x. You divide by 40 to get rid of anything close to the x. And now you're just doing 600 divided by 40, which really should give us 15 because we found that to be the answer already. And you can do it on the calculator, and I guarantee it will give you 15. So you kind of have two ways to do that. But I would just look at this and realize, all right, well, if it's 5 mLs, how many MEq is it? It's 10 MEq. There's a 2-to-1 ratio here. So that's something you can just keep in mind when you look at these meds. All right. All right, so this one says a healthcare provider's prescription reads clindamycin phosphate, 0.3 grams and 50 mLs normal saline to be administered IV over 30 minutes. The medication label reads clindamycin phosphate, 900 milligrams and 6 mLs. The nurse prepares how many mLs, so our answer has to be in mLs, of the medication to administer the correct dose, fill in the blank. So before I go into the textbook explanation and the textbook version of this, if you just wanted to picture it in your head, let's make it simple. You have some vial or an ampule, and in this thing, and when it's filled up all the way, it's 6 mLs, right? And that accounts for 900 milligrams. All right. What do we want? We want 0.3 grams. This could be an issue. How do I get from grams to milligrams? Well, 0.3 grams. All I have to do is move the decimal place over 3 spots. 1, 2, 3. Put zeros in there where the butt cheeks are. See the butt cheeks? So 300 milligrams. So that's what we want. We want 300 milligrams. Well, if 900 milligrams are in 6 mLs, doesn't it make sense? I've just got to use less. So how do I go from 900 to 300? Or how do I go from 9 to 3? You take a third. So that means in this vial or ampule or bag, whatever you have, you just take a third of it. All right, when you put the needle in and you draw up into the syringe, you take a third. So what's a third of 6 mLs? It's just 2. So 2 mLs is your answer. And you're done. Now, that didn't make sense, the picture was annoying, it didn't work, just use what they use in the textbook. They say your desired dose all over your available dose times the mLs of your available dose. Or you're basically saying the mLs of what you have available. All right. So desired dose. We said 0.3 grams, but we converted that, right? So that was 300 milligrams. Available dose. Well, it's in 900 milligrams. And what is it in? It's in 6 mLs, right? That's the mLs of what we have available. 6 mLs. Same thing, 3 over 9 is a third, and a third of 6 is 2. You're done. All right, number 145. A healthcare provider's prescription reads phenytoin, Dilantin, 0.2 grams orally twice daily. Kind of a mouthful, but we can we'll underline it and know that's the order. The medication label states that each capsule is 100 milligrams. So I could write 1 capsule equals 100 milligrams if I wanted to. The nurse prepares how many capsules? All right. So the only issue I really see here is at 0.2 grams. So let's convert into milligrams. 0.2 grams. How did I say to do it on the last problem? 1, 2, 3. You go 3 to the right. You put zeros in there. So 0.2 grams is the same thing as 200 milligrams. So they really want 200 milligrams orally 2 times a day. Okay? So maybe once in the morning, once at night. How many capsules do you administer in one dose? Well, if it's twice a day, we're just looking at 1 time. So in the morning, they're supposed to get 200 milligrams. So if that's the case, you just get 2 capsules. And that's it. Let's move on to the next one. A healthcare provider prescribes 1,000 mLs of normal saline to infuse over 8 hours. The drop factor is 15 drops per ml. The nurse sets the flow rate at how many drops per minute. So again, we're using our formula from last time, right? What was it? Volume times drop factor all over time in minutes. So our volume is 1,000. Our drop factor is what? 15. And what is our time? To infuse over 8 hours. Well, again, we don't want to put 8 hours here and get the question wrong. So we're going to we're going to convert to minutes. So 8 hours times 60. I should have wrote the other way. Times 60. 0 is 480 minutes. So that's what's going on the bottom there, 480 minutes. So just use a calculator. 1,000 times 15 equals divided by 480, 31.25. Hopefully that's what you got, 31.25 GTT per minute. Drops per minute, and round to the nearest whole number, 31. And you're done. All right, number 147. This one says a healthcare provider prescribes heparin sodium, 1,300 units per hour by continuous IV. So that's what the provider wants. They want, or the desired, is 1,300 units per hour, right? Sorry, that was weird. The pharmacy prepares the medication and delivers an IV bag labeled heparin, 20,000 units in 250. Thanks, pharmacy. Thanks for making it hard on us. An infusion pump must be used to administer the medication. The nurse sets the infusion pump at how many mLs per hour to deliver this desired dose here. So I'll do it maybe like the old school math way or like the high school math way, where you could just say, well, if we've got 20,000 units per 250, right? I want to know how many mLs is 1,300 in that bag. So 1,300 is a lot less. So this is units per ml, and this is units per, we don't know, so we call it X. You can cross multiply, right? So we can just use our calculator. 1,300 times 250. All right, gives us this nasty number, 325,000 equals 20,000, and that's 20,000x. We divide by 20,000, divide by 20,000. What do we get? Divide by 20,000, We get 16.25. 16.25 is x. And what was x? It was mLs. So 16.25 mLs it goes with 1,300, or 1,300 units of heparin is equal to 16.25 mLs. So now we need to do how many mLs per hour? Well, it's going to be, I think we just answered the question. Yeah, how many mLs per hour? So they want, if we want 1,300, you're going to put it at 16.25 or 16 mLs per hour. So I guess that's one way how to do it. And I think that's the way I'm going to stick with for right now.